Hello friends, welcome to my channel. Today we are going to solve question number 50 from GATE 2022. This is a complex analysis question. We are given a Mobius transformation T such that image of 3 points are given. T of 0 is equal to alpha, T of alpha is equal to 0, T of infinity is equal to minus alpha, where alpha is minus 1 plus I divided by root 2. Now let L denote the straight line passing through the origin with slope minus 1, and let C denote the circle of unit radius centered at the origin. So we have to find out which of these four statements are true. Okay, so statement A is T maps L to a straight line, B is T maps L to a circle, C is T inverse maps C to a straight line, and D is T inverse maps C to a circle. Okay, so first let's find out what is this Mobius transformation, formula for this Mobius transformation. Okay, so we have one property of Mobius transformation which says it preserves the cross ratio, right? It means cross ratio of z1, z2, z3, z4 is equal to cross ratio of its images, t of z1, t of z2, t of z3, t of z4, right? So this means what is the cross ratio? We can write it as z1 minus z3 into z2 minus z4 divided by z2 minus z3 into z1 minus z4, which is equal to t of z1 minus t of z3 into t of z2 minus t of z4 divided by t of z2 minus t of z3 into t of z1 minus t of z4. Okay, so now we have 3 points, 0, alpha and infinity, and we have to find a formula for t of z, right? T of z is equal to what? So assume z1 is equal to z, z2 is equal to 0, z3 is equal to alpha, and z4 is equal to infinity. So put these values in this equation, we get z minus alpha into 0 minus infinity divided by 0 minus alpha into z minus infinity is equal to, now on this right hand side just replace all these by their images, so we get t of z minus, what is t of alpha? It is 0. Other bracket, t of 0 is alpha minus t of infinity is minus alpha. This divided by t of 0, which is alpha, minus t of alpha, which is 0. Other bracket, t of z minus t of infinity is minus alpha. Okay, so let's solve this. Oh, and one more property we have about the cross ratio, which is if there is infinity in any of these these four terms, then we discard those factors, we cancel those factors, we do not write those factors. So we will not write these two factors because it includes infinity. Okay, so this becomes z minus alpha divided by minus alpha, which is equal to t of z, alpha minus minus alpha becomes twice alpha divided by alpha into t of z plus alpha. Okay, so this alpha alpha will get cancelled, so here we are left with t of z upon t of z plus alpha. Okay, so let's solve this for t of z. This implies z minus alpha t of z plus z minus alpha into alpha, which is equal to minus alpha t of z. Let's take t of z on one side. We get z minus alpha plus alpha into t of z is equal to minus z minus alpha into alpha. So this implies minus alpha plus alpha 0. So t of z is equal to minus alpha into z minus alpha divided by z. So it seems that we forgot this 2 here. So let's write it again. We get 2 t of z here. So 2 will be here. Okay. So twice alpha. Okay, so it gives us z plus alpha in the new denominator here. Yes. Okay, so this is t of z. Now we have formula for t of z, so we can proceed. Okay, so first let's find out image of L. What is L? L is a straight line with slope -1 passing through the origin. Right, so if we draw a diagram, it passes through the origin and its slope is -1, so it will be something like this, and this line is imaginary of z is equal to minus real of z, right? So basically L is this. Okay, now we have one more property about Mobius transformations, which is it maps a circle to a circle or a straight line, and it maps a straight line to a straight line or a circle. So we have only two options for image of a circle and image of a straight line, right? So we just have to, L is a straight line, so we just have to find out if image of L is circle or a straight line. Okay, so for that, let's make use of what something that is already given to us. We have given t of 0 is equal to alpha, t of alpha is equal to 0, and t of infinity is equal to minus alpha. Now note that 0 belongs to L, right? And t of 0 is alpha. Also alpha, what is alpha? Alpha is -1 plus I by root 2. So imaginary of alpha is 1 by root 2 and real of alpha is -1 by root 2. So they differ by a sign, right? So alpha also belongs to L and t of alpha is 0. The third point is infinity, and t of infinity is equal to minus alpha. Again, we can look at infinity as something that is on line L, because L is an infinite line. So we can look at L infinity as a point on L. So infinity belongs to L and t of infinity is equal to minus alpha. So is there a circle containing these 3 points, or there it is a line? So if we look on this plane, complex plane, alpha is this -1 plus I by root 2, so it will be here. Yes, somewhere here. And it is also on L, so it will be here. 0 is here, and again minus alpha will be here. So it means that t of L is L, right? Which is a straight line. So this means that t of L is a straight line, that is T maps L to a straight line. They believe that's option A. Let's check once which option is that. T maps L to a straight line. Yes, that is option A. So option A is correct. And automatically A is correct, so B is wrong. Now we just have to find out image of T inverse. Image of C under T inverse, right? Okay. Now C is a unit circle centered at origin, right? So, okay. So C is Z belongs to C such that modulus of Z is equal to 1, right? Okay. Now, if we note what is mod alpha? Mod alpha is 1 by root 2 squared plus, sorry, minus 1 by root, plus 1 by root 2 squared and whole square root. So this is 1. 1 by root 2 square is 1 by 2 plus 1 by 2. So 1 and square root of 1 is 1. So alpha belongs to C, right? And we have T of 0 is equal to alpha. So it implies T inverse of alpha is 0. Again, alpha belongs to C, so minus alpha also belongs to C, and T inverse of minus alpha is equal to infinity, right? Okay, so is there a circle containing both 0 and infinity? Definitely not. So also T inverse is also a Mobius transformation. So image of C under T inverse is either a line, straight line, or a circle. So it cannot be a circle for sure because 0 and infinity cannot lie on a same circle. So it definitely must be a straight line. So from this T inverse maps C on a straight line. Okay, 2 is a better word in this. Okay, T inverse maps C to a straight line, right? So let's check which option is that. T inverse maps C to a straight line. Okay, so that's option C. Okay, so options A and C are correct here. Okay, so I hope you all understood this solution. See you in the next video. Thank you.